Antarctica, a name that conjures images of a vast, icy expanse, a place where the elements reign supreme and the landscape is both beautiful and forbidding. A continent at the bottom of our world, shrouded in mystery and wonder. It is a land that has fascinated explorers and scientists for centuries, drawing them to its icy shores in search of knowledge and adventure. It is a place of extremes, a realm of ice and snow where temperatures can plummet to unimaginable lows. The landscape is dominated by towering icebergs and vast ice sheets that stretch as far as the eye can see. The coldest, windiest and driest continent on Earth. Here, the weather can change in an instant with fierce storms and blizzards that can last for days, making survival a constant challenge. Yet beneath its icy exterior lies a world of mystery and wonder. Hidden within the ice are clues to our planet's past, secrets that scientists are only beginning to uncover, a hidden world waiting to be discovered. Scientists brave the harsh conditions, venturing into ice caves and drilling deep into the ice to unlock the secrets of this frozen continent. For centuries, explorers and scientists have been drawn to Antarctica's stark beauty. From the early expeditions of the 19th century to the modern research teams of today, the allure of this frozen land has remained strong. They brave the harsh conditions, seeking to unlock its secrets. Equipped with the latest technology, they study the ice, the atmosphere, and the unique ecosystems that thrive in this extreme environment. What they find is a story of ancient landscapes, unique life forms, and a delicate balance that affects us all. The ice holds a record of Earth's climate history, revealing patterns and changes that have occurred over millennia. Antarctica is a land of contrasts. It is a place where the harshest conditions coexist with breathtaking beauty, where the frozen landscape is both desolate and teeming with life. Towering glaciers rise from the frozen ocean, their icy fingers reaching towards the horizon. These massive ice formations are constantly shifting and changing, a reminder of the dynamic nature of this frozen world. Vast plains of snow and ice stretch as far as the eye can see, broken only by the occasional mountain peak. The sheer scale of the landscape is awe-inspiring, a testament to the power of nature. This is a place of raw, untamed beauty. The pristine ice fields and untouched scenery offer a glimpse into a world that remains largely unchanged by human activity. But Antarctica is more than just a frozen wasteland. It is a place teeming with life, both above and below the ice. The unique ecosystems that have adapted to this harsh environment are a testament to the resilience of life. It is a place teeming with life, both above and below the ice. Penguins waddle along the shores, their distinctive black and white feathers standing out against the stark white landscape. Penguins waddle along the shores, their distinctive black and white feathers standing out against the stark white landscape. These charismatic birds are just one example of the incredible wildlife that calls Antarctica home. While seals and whales patrol the icy waters, these marine mammals are perfectly adapted to the cold, thriving in the nutrient-rich waters that surround the continent. And beneath the frozen surface, in the darkness of subglacial lakes, extraordinary creatures thrive in conditions we are only beginning to understand. These hidden ecosystems are a reminder of the incredible diversity of life on our planet, even in the most extreme environments. Antarctica is a desert, not a desert of sand and scorching sun, but a desert of ice and snow. This vast frozen expanse is one of the most extreme environments on Earth, where temperatures can plummet to below -80 degrees Fahrenheit. The wind howls across the barren landscape, creating blizzards that can last for days. It is the largest desert on Earth, covering an area twice the size of Australia. Despite its harsh conditions, Antarctica is a place of stunning beauty and stark contrasts. The endless white horizon is punctuated by jagged mountain peaks and deep crevasses. The ice sheet, a vast expanse of frozen water, dominates the landscape. This ice sheet holds about 60% of the world's fresh water, locked away in its frozen state. The sheer scale of this ice is almost unimaginable. In places, it is over 2 miles thick. The weight of this ice is so immense that it has depressed the land beneath it by hundreds of feet. This ice has been accumulating for millions of years, layer upon layer, each one a snapshot of the past. These ice sheets hold a record of Earth's past climate. By studying the layers of ice, scientists can learn about the conditions on Earth thousands, even millions of years ago. Each layer of ice contains tiny bubbles of ancient air, trapped when the snow first fell. Scientists drill deep into the ice, extracting long cylinders called ice cores. These ice cores are meticulously analyzed in laboratories around the world. They provide a wealth of information about past temperatures, atmospheric composition, and even volcanic eruptions. These cores are like time capsules containing trapped air bubbles and particles that tell us about the atmosphere from hundreds of thousands of years ago. By examining these tiny bubbles, scientists can reconstruct a detailed history of Earth's climate. The ice cores reveal how Earth's climate has changed over time. They show us periods of warming and cooling, and they provide valuable clues about the impact of human activities on our planet. This information is crucial for understanding how our climate might change in the future. They show us periods of warming and cooling, and they provide valuable clues about the impact of human activities on our planet. The data from these ice cores is used to create models that predict future climate scenarios. By studying these icy archives, scientists can better predict future climate change. They can see how natural factors and human activities have influenced the climate in the past and use this knowledge to forecast future changes. By studying these icy archives, scientists can better predict future climate change. They can see how natural factors and human activities have influenced the climate in the past and use this knowledge to forecast future changes. This research is vital for developing strategies to mitigate the effects of climate change. The glaciers themselves are constantly on the move, flowing slowly but relentlessly towards the sea. This movement is driven by the immense weight of the ice and the force of gravity. As the glaciers move, they shape the landscape, carving out valleys and fjords, flowing slowly but relentlessly towards the sea. This movement is driven by the immense weight of the ice and the force of gravity. As the glaciers move, they shape the landscape, carving out valleys and fjords. The journey of these glaciers can take thousands of years. As they reach the coast, they break off into massive icebergs, some larger than cities. These icebergs are a dramatic reminder of the power and scale of the natural world. They can drift for years, slowly melting and releasing their fresh water back into the ocean. These icebergs drift across the Southern Ocean, carried by currents and winds. They are a vital part of the ocean ecosystem, providing habitats for marine life and influencing ocean circulation patterns, slowly melting and releasing their fresh water back into the sea. This process is a crucial part of the global water cycle, affecting sea levels and ocean salinity. The story of Antarctica is one of ice and water, past and future, and the delicate balance of our planet's climate. The ice cores extracted from Antarctica's depths are more than just frozen water. They are time capsules, preserving the history of our planet in their frozen layers. Each layer of ice represents a different period in Earth's past, capturing the atmospheric conditions of that time. These ice cores are invaluable to scientists who seek to understand the changes our planet has undergone over millennia. They are a library of Earth's history, meticulously catalogued and stored in cold facilities around the world. Each core is carefully labeled and preserved, ensuring that the information they contain remains intact for future generations of researchers. Trapped within their layers are tiny bubbles of ancient air, perfectly preserved for millennia. These bubbles are like tiny time capsules, offering a direct link to the atmosphere of the past. By analyzing the gases trapped in these bubbles, scientists can reconstruct a detailed picture of the Earth's climate history. These bubbles offer a glimpse into the atmosphere of the past, revealing its composition and temperature. By studying the ratios of different gases, such as carbon dioxide and methane, scientists can infer the temperature and climate conditions of different periods in Earth's history. Scientists painstakingly analyze these air bubbles, measuring the concentration of different gases like carbon dioxide and methane. This process involves sophisticated instruments and meticulous techniques to ensure accurate readings. The data obtained from these analyses is crucial for understanding the natural variability of greenhouse gases and their impact on the climate. By comparing these levels to those in our current atmosphere, they can track the rise and fall of greenhouse gases over time. The results are striking. They reveal a clear pattern of increasing greenhouse gas concentrations, particularly since the onset of the Industrial Revolution. The ice cores show a dramatic increase in greenhouse gas concentrations since the Industrial Revolution, coinciding with human activities like burning fossil fuels. This period marks a significant shift in the Earth's atmospheric composition, driven by industrialization and the widespread use of fossil fuels. The ice cores also contain clues about past climate events. Each layer of ice can tell a story about the conditions on Earth at that time. For example, variations in the thickness and composition of the layers can indicate periods of heavy snowfall or drought. Layers of volcanic ash reveal periods of intense volcanic activity, which can cool the planet by blocking sunlight. These volcanic events are recorded in the ice cores as distinct layers of ash, providing a timeline of volcanic activity and its impact on the climate. Other layers show evidence of past ice ages and warm periods, providing insights into the natural cycles of Earth's climate. By studying these layers, scientists can identify patterns and trends in the Earth's climate history, helping to predict future climate changes. By understanding how Earth's climate has changed in the past, scientists can better model its future behavior. These models are essential for predicting the potential impacts of current and future greenhouse gas emissions on the global climate. The ice cores serve as a stark reminder of the interconnectedness of our planet's systems and the lasting impact of human actions. They highlight the importance of preserving our environment and taking action to mitigate the effects of climate change. As we continue to study these frozen archives, we gain a deeper understanding of our planet's past, present, and future. Despite the extreme cold and lack of sunlight, life finds a way in Antarctica. On the surface, penguins, seals, and seabirds thrive in the rich waters surrounding the continent. But even beneath the thick ice hidden from view, life persists. Scattered across Antarctica are hundreds of subglacial lakes, bodies of fresh water trapped beneath the ice sheet. These lakes are home to unique ecosystems that have evolved in complete isolation for millions of years. These hidden worlds are like time capsules, harboring life forms found nowhere else on Earth. In recent decades, scientists have drilled through the ice into these subglacial lakes. Bringing back samples of water and sediment, they have discovered a surprising diversity of microorganisms, including bacteria, archaea, and even small crustaceans. These extremophiles, as they are called, have adapted to survive in conditions that would be deadly to most other life forms. The discovery of life in these extreme environments has profound implications for our understanding of the limits of life itself. It suggests that life may exist in other seemingly inhospitable places, such as the icy moons of Jupiter and Saturn.